Right now, somewhere above the dense atmosphere that shields your fragile biology from the vacuum, the universe is burning. It is doing what it has done for 13.8 billion years. It is screaming in silence. You cannot hear it. You can only see the static, the ancient photons that have traveled across the howling void to die on your retina. Go outside, tonight. Find the darkest patch of sky you can. If you are lucky, if you are far away from the light pollution of the cities that act as cataracts on the human eye, you might see them. 3,000 points of light. That is the limit of human biology. 3,000 furnaces suspended in the cold. It feels majestic. It feels like a cathedral. But this feeling is a lie. What you are seeing is not the universe. You are seeing the dust on your own window pane. You are seeing the neighbors in your own backyard. This is the great deception of the night sky. It convinces you that you have a view. It convinces you that you are looking out into the cosmos. You are not. You are looking at a microscopic fraction of a percent of reality. And if you knew the true number of what lies beyond that curtain of darkness, if you could truly comprehend the scale of the inferno raging around us, you would not sleep. You would not feel awe. You would feel a crushing, absolute claustrophobia. We are going to conduct a census. We are going to attempt to answer the oldest question, the one that every child asks and every astrophysicist dreads. How many stars are there? But be warned. In this line of inquiry, the numbers cease to function as mathematics. They become monsters. They stop quantifying reality and start dismantling your sense of place within it. To understand the number, we must first understand the unit, a single star. We speak of them casually. Twinkle, twinkle. We draw them with 5 points on a piece of paper. But a star is a violent, chaotic tear in the fabric of thermodynamics. Picture a nuclear explosion, the kind that flattens cities, melts flesh, and turns sand into glass. Now imagine that explosion never stops. Imagine it detonating every single second, for billions of years, held together only by the crushing weight of its own gravity. That is one star, one engine of destruction. Our sun is a mediocre example. It is a yellow dwarf, a steady, middle-aged furnace. And yet, inside it, you could fit 1 million Earths, 1 million of our entire worlds, consumed by a single sphere of plasma. If you were to shout into the void, assuming sound could travel, it would take your voice 14 years to cross the diameter of the largest known star, Stephenson 218. 14 years of screaming just to travel from one side of an object to the other. Keep that scale in your mind. Hold it there. It is the anchor. Because we are about to cut the chain, let us step back. Let us leave the Earth, leave the solar system, and float in the dead space of the interstellar medium. As we pull back, the sun shrinks. It becomes just another dot. It joins the river. This is the Milky Way, our home. It is a barred spiral galaxy, a grand spinning pinwheel of gas, dust, and dark matter. For decades, we tried to count the inhabitants of this city. We used radio telescopes to peer through the thick, choking clouds of dust that obscure the galactic core. We measured the rotational speed of the galaxy, feeling the gravitational tug of unseen masses. The estimates came back, and they were staggering. 100 billion. That is the conservative estimate, the lower bound, 100 billion stars in the Milky Way alone. Let's try to visualize that. The human brain cannot handle billions. It shuts down, it rounds off. So let us use an analogy. Imagine a handful of sand. Not the beach, just a handful. coarse, gritty grains slipping through your fingers. There are roughly 10,000 grains of sand in a handful. To get to 100 billion, you would need 10 million handfuls. You would need to fill a dump truck. Now, imagine every single one of those grains is a sun. And around every single one of those grains, there are planets, worlds, some frozen, some boiling, some perhaps teeming with things that look up and wonder if they are alone. But the Milky Way is not a quiet place. It is a graveyard and a nursery. Every year, roughly 7 new stars are born in our galaxy, condensing out of the cold molecular clouds like raindrops forming in a storm. And every century or so, a massive star runs out of fuel and collapses, detonating in a supernova that briefly outshines the entire galaxy. So, 100 billion stars. That is our neighborhood. That is the local inventory. If the universe ended at the edge of the Milky Way, the scale would already be enough to drive a sentient mind to madness. But the universe doesn't end there. The Milky Way is merely an island, a lonely raft drifting in a much, much darker ocean. To count the rest, we have to look into the deep. In 1995, humanity did something audacious. We took the Hubble Space Telescope, one of the most precise instruments ever built, and we pointed it at nothing. We aimed it at a tiny patch of sky near the handle of the Big Dipper. It was a blank space. To the naked eye, it was empty blackness. There were no stars there, no light, just the void. Scientists argued against it. They said it was a waste of precious telescope time. Why stare at the dark? Why photograph the nothingness? But the director of the institute insisted. They opened the shutter. They let the telescope stare at that single point of blackness for 10 consecutive days. It was soaking up photons, catching the faintest trickles of light that had been traveling for eons. When they processed the image, the room went silent. It wasn't empty. The image, known as the Hubble Deep Field, contained 3,000 galaxies. Not stars. Galaxies. Spiral galaxies, elliptical galaxies, irregular wrecks of cosmic collisions. In a patch of sky the size of a grain of rice held at arm's length, there were 3,000 islands of light, and each one of those islands contained its own 100 billion stars. Do the math. Multiply the grain of rice by the entire surface area of the night sky. The numbers begin to hemorrhage. They begin to bleed out of the realm of comprehension and into the realm of abstract horror. If you assume the Hubble Deep Field is representative of the entire sky, and the cosmological principle tells us it is, that the universe is homogeneous and isotropic on large scales, then we are not talking about billions anymore. We are talking about 2 trillion galaxies, 2 trillion cities of light, each one harboring hundreds of billions of suns. Let us put the number on the table. It is an estimate, a flickering guess in the dark, but it is the best we have. The number of stars in the observable universe is roughly 200 sextillion. That is a 2 followed by 23 zeros. 200,000, 1,000,000,000,000,000,000. Let us return to the sand. Go to the beach. Not just a handful this time. Look at the beach. Look at the dunes stretching for miles. Look at the coastlines of all the continents on Earth. The Sahara, the Gobi, the bottom of the Pacific Ocean. If every grain of sand on every beach and every desert on Earth represented a single star, it would not be enough. The number of stars in the universe exceeds the number of grains of sand on our entire planet. Pause. Let the silence of the room settle around you. There are more nuclear furnaces burning in the sky than there are specks of silica on Earth. This should be a moment of triumph. We have counted the treasure. We are rich in worlds. But here is where the story shifts. Here is where the thrill of the large number turns into the chill of the implication. Because if there are that many stars, where is the light? This is known as Olbers Paradox, and it is the first crack in the sanity of our model. The logic is simple. If the universe is infinite and filled with an infinite or near infinite number of stars, then every line of sight from your eye should eventually end on the surface of a star. No matter where you look, you should see a sun. The night sky should not be black. It should be as bright as the surface of the sun. The earth should be vaporized by the sheer, relentless radiation of a star-filled canopy. There should be no night. There should be only blinding, searing white. But you look up, and you see darkness. Why? The standard answer is comforting. It tells us that the universe is not infinite in age. It began some time ago, 13.8 billion years, and light travels at a finite speed. Therefore, the light from the most distant stars hasn't reached us yet. We are seeing a universe that is still turning on. But there is a darker interpretation, one that fits the data just as well, but suggests a far more hostile reality. The universe is expanding. We know this. But it is not just expanding. It is stretching. The space between the galaxies is growing. And it is growing faster and faster. This expansion stretches the light traveling through it. It takes the angry, high-energy white light of distant stars and pulls it apart, stretching the wavelength until it shifts red, then infrared, then into microwaves, and finally into radio waves. The light is still there, but it has been shifted out of the visible spectrum. The universe is actually blazing with radiation, but our eyes are blind to it. We are swimming in a sea of invisible fire, and we call it darkness. But the expansion implies something else, something catastrophic. It implies that we are losing them. Every second that ticks by on your watch, a galaxy crosses the cosmic horizon. It moves past the point of no return. The space between us and them expands faster than light can travel. Their light will never reach us again. They are effectively deleted from our reality. So when we count to 200 sextillion, we are counting ghosts. We are conducting a census of a graveyard. A significant percentage of the stars we see in the deep field imagery are already gone. They have moved beyond the observable horizon. We are looking at their after images. If you could teleport to where they were supposed to be, you would find nothing but empty, expanding void. We are alone in a way that is difficult to articulate. We are stranded on a tiny rock, drifting in a galaxy that is slowly becoming isolated from the rest of the cosmos. The count is high, yes. The number is astronomical. But the accessibility is zero. And yet, the horror is not just in the stars we can't reach. It is in the stars that shouldn't exist at all. Recently, the James Webb Space Telescope, the successor to Hubble, the golden eye we launched to peer even deeper into the abyss, sent back data that broke the models. It looked back to the very dawn of time, to the epoch just a few 100 million years after the Big Bang. According to our best physics, the universe at that age should have been chaotic, hot, and messy. There should have been small, scraggly baby galaxies, just starting to form. But that is not what Webb saw. Webb saw monsters. It saw massive, fully formed, bright galaxies sitting at the edge of time. They were too big, too bright, too old. It was as if you walked into a nursery and found fully grown adults sitting in the cribs, staring back at you. This is the crisis in cosmology. These impossible galaxies suggest that our timeline is wrong, that our understanding of how stars form is wrong, or perhaps that the universe is older than we think. Perhaps infinite cycles of older universes are bleeding through. We counted the stars, and the stars laughed at us. They do not follow our rules. We have established the scale, 200 sextillion, a number so large it renders human endeavor statistically irrelevant. We have established the trap, the expansion that is stealing these stars from us, pulling them into the unobservable dark. But there is a catch, a paradox that haunts the corridors of speculative astronomy. With 200 sextillion stars, with unimaginable amounts of energy, heat, and potential for life, why is it so quiet? If even 1 in a billion stars has a planet, and 1 in a billion of those planets has life, and 1 in a billion of those civilizations survives to build a radio transmitter, the sky should be screaming. We should be detecting signals, megastructures, leakage, noise. Instead, we have the great silence. We point our dishes at the 200 sextillion furnaces, and we hear nothing but the hiss of the Big Bang's background radiation. This brings us to a terrifying possibility. A possibility that turns the star count from a majestic number into a countdown. Maybe the stars are not friendly fire. Maybe they are ticking clocks. To understand why the sheer number of stars is a threat, we have to look at what a star actually is. We called it a furnace earlier. But that is too passive. A star is a gravity well. It is a master of distinct manipulation of space-time. And right now, something is wrong with the count. We think there are 200 sextillion, but the motion of the galaxies suggests there is mass we cannot see, the dark matter halo. But what if that mass isn't just exotic particles? What if the census is missing the corpses? Stars die. We know this. But how they die matters. Most shrink into white dwarfs. Some explode. But the biggest ones, they punch a hole in the bottom of the universe. They become black holes. We have begun to suspect that the universe is teeming not just with burning stars, but with dead ones. Wandering black holes. Invisible, rogue singularities moving through the dark, unmoored from any solar system. If the visible stars are the streetlights, the black holes are the open manholes between them. And we have no map for those. We are drifting through a minefield without a detector. But let's go deeper. The visible stars, the ones we can see, are deceiving us in another way. They look stable. Our sun looks stable. It rises, it sets, it provides heat, it allows for photosynthesis. It allows for you to sit there and listen to this. But the sun is a chaotic fluid. It is governed by magnetic fields that twist and snap. And recently, we have seen stars do things they shouldn't. We have seen the great dimming of Betelgeuse. We have seen stars vanish, literally vanish. One moment they are there on the photographic plate, the next moment, gone. No supernova, no slow fade, just deletion. Astronomers call it the Vanishing and Appearing Sources During a Century of Observations project. VASCO. They have found hundreds of transients, lights that were there, and now aren't. Where did they go? Did they collapse directly into black holes, skipping the explosion? That is theoretically possible, but terrifying. It implies a failed supernova, where the star is simply swallowed whole from the inside out, or is something else blocking the light. Imagine a Dyson sphere, a shell built around a star by an advanced intelligence to harvest its energy. If the shell is completed, the star disappears from the visible spectrum. It vanishes. If the 200 sextillion number is correct, and we see stars vanishing, are we watching a civilization turn out the lights? The scale of the universe is not just a spatial problem, it is a temporal one, and it is a probability problem. When you look at the number 200,000 tamausen sanadanamu, you are looking at a casino where the house always wins. The odds of a catastrophic event, a gamma-ray burst, a wandering neutron star, or a vacuum decay event happening somewhere are 100%. The question is not if the stars will kill us. The question is, which one? To understand why the number 200 sextillion is not a comfort, but a threat, we have to look under the hood. We have to strip away the poetic imagery of balls of gas and look at the terrifying mechanics of what a star actually is. Because when you look at the sun, you are not looking at a fire. Fire is a chemical reaction. It is the oxidation of fuel. It is gentle. It is quaint. What you are looking at is a thermonuclear bomb that is detonating continuously, held in check only by its own oppressive weight. Imagine you are trapped in a room. The ceiling is made of lead, and it weighs billions of tons. It is falling. It is crushing down on you with the force of gravity. To keep it from flattening you into a smear of subatomic paste, you have to push back. But you don't push back with your hands. You push back with explosions. You have to detonate a nuclear warhead every single second, right in your face, just to generate enough pressure to hold up the ceiling. That is the life of a star. It is a desperate, violent stalemate between two godlike forces: gravity, which wants to crush the star into a singularity, and fusion, which wants to blow the star apart into dust. For billions of years, the star balances on this knife edge. It crushes hydrogen atoms together, forcing them to fuse against their will, transforming mass directly into energy. This is the proton-proton chain. It is a process so violent that a single photon, a single particle of light created in the core, can take 100,000 years to fight its way to the surface. It is a prison riot of particles, bouncing, scattering, and screaming in the dense, crushed heart of the star. And we are fragile byproducts of this violence. You have heard the phrase, "We are made of star stuff." Carl Sagan said it. It is on t-shirts. It sounds beautiful. It implies a connection, a celestial heritage. But strip away the romance, and the horror reveals itself. We are not made of star stuff. We are made of nuclear waste. The carbon in your DNA, the calcium in your bones, the iron in your blood. These are the ashes of dead stars. They are the leftovers found in the cosmic incinerator. The universe started with hydrogen and helium, clean, simple, sterile. Everything else, everything that makes you, you, was forged in the crushing pressure of a dying sun. A star spends its life burning clean fuel and turning it into dirty, heavy elements. It is a pollution engine, and eventually it chokes on its own waste. The most terrifying element in the universe is not plutonium or uranium, it is iron. Iron 56. In the core of a massive star, fusion climbs the ladder. Hydrogen to helium, helium to carbon, neon, oxygen, silicon. The star burns hotter and faster, desperate to keep the ceiling from falling. But when it fuses silicon into iron, the game ends. Iron is the cosmic killer. Fusing iron does not create energy. It consumes it. It is an energy sink. The moment a massive star creates iron in its core, the pressure disappears. The bomb stops detonating. The ceiling falls. In a fraction of a second, literally less time than it takes you to blink, the core collapses. The outer layers, trillions of tons of gas, rush inward at 25% the speed of light. They hit the iron core, bounce off, and tear the star apart. This is a supernova. It is an event so violent that for a few weeks, a single star outputs more energy than the rest of the galaxy combined. And this brings us back to the numbers. If there are 200 sextillion stars, and if the universe is roughly 13.8 billion years old, then supernovae are not rare. They are happening everywhere, right now. In the time it took you to listen to this sentence, roughly 30 stars in the observable universe just died. 30 massive explosions. 30 systems wiped clean of life. We're walking through a field of landmines, and the explosions are silent because space is a vacuum. But the radiation is real. If a supernova were to go off within 30 light years of Earth, it wouldn't just be a bright light. It would be an extinction event. The gamma rays would strip our ozone layer in seconds. The solar wind would become a blowtorch. The atmosphere would ionize. The surface of the Earth would differ little from the inside of a microwave oven. We have scanned our local neighborhood. We think we are safe. The nearest candidate, Betelgeuse, is over 600 light years away. It is safe distance, we think. But distance is relative, and stars move. This is the next layer of the horror. The fixed stars is a lie. The constellations you see, Orion, Ursa Major, Cassiopeia, are temporary graffiti. They are a snapshot of a slow-motion explosion. Every star is moving. The Sun is orbiting the center of the Milky Way at 500,000 miles per hour. We are drifting, and so is everything else. Usually, this traffic is orderly. It flows like water in a drain. But sometimes, there are accidents. Meet the rogue stars. Occasionally, a binary star system wanders too close to the supermassive black hole at the center of the galaxy. The black hole, Sagittarius AR, disrupts the dance. It captures one star and flings the other away. It acts like a gravitational slingshot. The ejected star is accelerated to millions of miles per hour. It becomes a hypervelocity star. These are cosmic bullets. They are stars that have been unmoored from gravity, screaming through the void, crossing the galaxy in a fraction of the normal time. We have found them. A star named S5 HVS1 is currently exiting the Milky Way at 4 million miles per hour. But what if one was headed towards us? You would not see it coming until it was too late. It takes centuries to cross the void, but space is dark. A rogue red dwarf, dim and small, could pass through the Oort cloud, the shell of comets surrounding our solar system, without us ever seeing its light. But we would feel it. Gravity is infinite in reach. As the rogue star passes, it would disturb the comets. It would destabilize the delicate clockwork of our outer solar system. It would rain rocks down upon the inner planets, a bombardment that could last for 1,000,000 years. Or, if it passed closer, it could eject Earth from the solar system entirely. Imagine that scenario. No collision, just a gravitational tug. The Earth is pulled out of its orbit. We drift away from the Sun. The days get longer, the light gets dimmer, the temperature drops, the oceans freeze, the atmosphere condenses into snow. We become a rogue planet, a frozen tomb drifting in the dark forever. It has likely happened to other worlds. With 200 sextillion stars interacting over billions of years, the number of ejected frozen planets drifting in the void is likely in the trillions. But let us focus on the stars that stay, the normal stars. We look for life. We look for Goldilocks zones, places where water is liquid and the temperature is mild. We assume that because we are here, The universe is hospitable. But the Sun is an anomaly. The Sun is a G-type main sequence star. It is yellow, stable, and relatively rare. The vast majority of the stars in the universe, 75% of them, are red dwarfs. These are the cockroaches of the cosmos. Small, dim, cool, and nearly immortal. A red dwarf burns its fuel so slowly that it can live for trillions of years. Long after the Sun has died and the Milky Way has gone dark, the red dwarfs will still be smouldering. If life exists in the universe by sheer statistical probability, it almost certainly exists around a red dwarf. But a red dwarf is not a home. It is a trap. Because they are so dim, the Goldilocks zone is very close to the star. To get enough heat, a planet has to orbit right next to the flame, closer than Mercury orbits the Sun. At that distance, gravity takes hold. The planet becomes tidally locked. This means the planet doesn't rotate relative to the star. One side of the planet faces the star forever. The other side faces the black void forever. Imagine a world where the Sun never sets. It hangs in the sky, a massive, unmoving red eye. The ground beneath it is a scorched desert, baked by constant radiation. Now, imagine the other side, eternal night. A frozen wasteland where the temperature is near absolute zero. The only habitable place on such a world would be the Terminator line, the thin strip of twilight between the burning day and the frozen night. A narrow ring of perpetual dusk where gale force winds scream constantly, driven by the massive temperature difference between the two hemispheres. That is the most common real estate in the universe. That is where the aliens likely are. Huddled in the twilight, trapped between fire and ice. And it gets worse. Red dwarfs are unstable. They are prone to massive magnetic flares. Without warning, they can double in brightness in minutes, blasting their nearby planets with X-rays and UV radiation. These flares would strip away the atmosphere. They would sterilize the surface. Any life trying to evolve on a red dwarf world would be periodically microwaved. So we have a universe filled with 200 sextillion stars. Most of them are unstable, dangerous, or actively hostile. But we still have not touched the true horror of the scale. We have spoken of the stars as individual threats. But they are part of a structure that is so large it defies logic. We live in a galaxy. The galaxy lives in a cluster. The cluster lives in a supercluster. When we map the positions of these millions of galaxies, we see a pattern. They are not scattered randomly. They are arranged in strands, filaments. The universe looks like a web, a cosmic spiderweb made of light. And between the strands, the voids, great empty bubbles of nothingness, millions of light years across, places where there are no stars, no galaxies, just pure, unadulterated dark. If you were teleported to the center of the Bhuta's void, the great nothing, you would see nothing, no stars. The nearest galaxy would be so far away, it would be invisible to your naked eye. You would float in total sensory deprivation. And this web is moving. Gravity is pulling the galaxies. They are flowing like rivers. We are currently falling towards the Virgo cluster. But the Virgo cluster is falling towards something else. Something massive. Something invisible. Something we cannot see because it is hidden behind the dust of our own Milky Way. Astronomers call it the Great Attractor. It is a gravitational anomaly hundreds of millions of light years away. It is pulling us. It is pulling our galaxy, Andromeda, and thousands of others. We are sliding towards it at 1.3 million miles per hour. We do not know what it is. It might be a concentration of mass so dense it defies our models, a cluster of superclusters, or something stranger. But we are being dragged. The entire starry sky you see at night is just the interior of a train car, and the train is hurtling towards a cliff we cannot see. This sense of motion, of uncontrolled destiny, brings us back to the psychological horror of the numbers. If the universe creates stars so easily, why is it so hard to leave them? The distances are the final lock on the prison cell. Let's go back to the car analogy. Imagine you are driving at 60 miles per hour. To drive to the Sun would take you 177 years. To drive to Proxima Centauri, the absolute nearest neighbour star, would take you 48 million years. 48 million years. That is the distance to the closest dot. The universe is not designed for travel. It is designed for isolation. The speed of light is not just a speed limit. It is a quarantine. It ensures that civilizations can almost never meet. We are shouting across a canyon so wide that the echo dies before it reaches the other side. This implies that the 200 sextillion stars are not opportunities. They are mirages. They are unreachable islands. Every star represents a potential failure, a potential civilization that rose, looked up, dreamed of the stars, realized they could never reach them, and then died on their homeworld. The sheer number of stars mocks us. It is an abundance we can never touch. It is like dying of thirst while floating in the middle of a salt ocean. And yet, there is one more twist in the physics of the stars that suggests the universe might be even more hostile than simple isolation. We have assumed the laws of physics are constant, that a star here works the same as a star 10 billion light-years away. But recent measurements of the fine structure constant, a number that dictates how light and matter interact, suggest that it might vary across the universe. This means there might be regions of the cosmos where stars cannot burn, regions where the laws of physics themselves are broken, regions where molecular bonds cannot hold. If the universe is not uniform, then our existence is even more precarious. We are not just on a lucky planet, we are in a lucky patch of space-time, a bubble of stability, in a chaotic, shifting multiverse. We have looked at the number, 200 sextillion. We have looked at the mechanics, fusion, gravity, collapse. We have looked at the environment, radiation, rogue stars, voids. We have established that the universe is a violent, churning machines that create stars only to destroy them, and perhaps us with them. But the story does not end with the present. The present is a fleeting snapshot. To truly understand the horror of the stars, we must look at where they are going. We must look at the timeline. Because stars are not eternal. They are fuel tanks, and the fuel is running out. The era of the stars, the stelliferous era, is a temporary phase. It is a brief flash of light in an eternity of darkness. We are living in the golden age of the universe. It doesn't feel like it, but this is as good as it gets. The sky is full of light. The galaxies are still forming, but the gas is being used up. The star formation rate in the universe peaked billions of years ago. It is dropping. The universe is getting tired. It is running out of breath. We are approaching the end of the party. The lights are starting to dim, and what comes next is the cold. The cold is not a weather event. It is a thermodynamic destiny. We are currently in the stelliferous era, the star-bearing age. It sounds permanent because it is all we have ever known. But to the universe, this era is nothing more than a camera flash, a brief, blinding moment of energy discharge between two eternities of darkness. We have counted the stars, 200 sextillion. We have catalogued the monsters. But now, we must look at the clock. The universe is efficient, ruthlessly so. It does not allow energy to be hoarded. It demands that energy be spread out, thinned, and neutralized. This is the second law of thermodynamics. Entropy. It is the only true God in the cosmos, the one law that cannot be broken, bargained with, or ignored. Entropy demands that the stars die. Let's fast forward. Let's accelerate the timeline. Let's watch the 200 sextillion lights go out, one by one. First, the massive blue giants go. They are the rock stars of the galaxy, living fast, dying young, exploding in violent supernovae. They will be gone within a few million years. The sky will lose its brilliant, piercing blue points. Then, the yellow stars like our sun. They are steady, but they are not eternal. In roughly 5 billion years, our sun will run out of hydrogen. It will panic. It will swell into a red giant, swallowing Mercury, Venus, and likely Earth. It will become a bloated, dying ember. Then, it will shed its outer layers, puffing them gently into space to create a planetary nebula, a colourful shroud for its own fuel. What remains will be a white dwarf, a hot, dense diamond the size of Earth, slowly cooling in the dark. The galaxy is now dimmer, redder, but the red dwarfs remain. Remember them, the cockroaches. They are stingy with their fuel. Proxima Centauri will keep burning for 4 trillion years, but 4 trillion years is not forever. Eventually, even the red dwarfs will exhaust their hydrogen. They will not explode, they will not swell, they will simply fade. They will turn into blue dwarfs, then white dwarfs, and finally, after incomprehensible eons, they will cool down completely. They will become black dwarfs. A black dwarf is a star that has died and frozen over. It emits no light. It emits no heat. It is a dead, black crystal ball floating in the void. We have never seen one. The universe is not old enough for one to exist yet, but they are coming. Let us jump to 100 trillion years in the future. The stelliferous era is over. Look at the sky then. It is pitch black. There are no stars. If you were standing on the surface of a frozen planet, your eyes would be useless. The 200 sextillion lamps have all burned out. The galaxies themselves have dissolved. Without the energy of active stars, the structures unravel. Stellar remnants, the black holes, neutron stars, and white dwarfs either get flung out into the void by gravitational interactions or spiral inward to be eaten by the supermassive black holes at the center. The universe is now a graveyard. It is composed of corpses and ghosts. This is the degenerate era. The only sources of energy left are the occasional collisions. 2 white dwarfs might crash into each other in the dark, igniting a Type 1a supernova. A brief, lonely firework in a cathedral of infinite shadow. It flashes for a few weeks, and then the dark returns. Civilizations, if they still exist, will have to huddle around the spinning corpses of neutron stars, harvesting the kinetic energy of their rotation. They will be scavengers, picking through the trash of the golden age we are living in right now. But it gets worse. The matter itself, the stuff you are made of, might not be stable. We assume protons are forever. But many grand unified theories of physics suggest that protons eventually decay. They have a half-life. It is an unimaginably long time, 10 to the power of 34 years, but in the deep time of the universe, everything that can happen will happen. This means that eventually the dead stars will dissolve. The planets will dissolve. Your body if it were preserved in ice, would simply disintegrate into radiation. The universe will literally rot. So, what is left? The monsters, the black holes. They are the winners of the cosmic game. When all the lights go out, the black holes will rule the dark. They will sweep up the remaining dust, the remaining gas, the remaining matter. They will grow fat and massive. For an era known as the black hole era, the universe will contain nothing but singularities, great, invisible mouths moving through the vacuum, but even they cannot escape entropy. Stephen Hawking taught us that black holes are not truly black, they leak. They emit a faint, ghostly radiation, Hawking radiation. They are slowly evaporating. The bigger they are, the slower they leak. A solar mass black hole takes 10 to the power of 67 years to evaporate. A supermassive galactic black hole takes 10 to the power of 100 years, a Google years. Try to visualize that number, a 1 with 100 zeros. It is a timescale that makes the entire history of stars, from the Big Bang to the death of the Sun, look like less than a nanosecond. But eventually, the clock strikes. The black holes will shrink. As they get smaller, they get hotter. In their final moments, they will explode, releasing their stored energy back into the universe in a shower of particles. And then, nothing. The dark era. The universe is now a sea of photons and neutrinos, cooling towards absolute zero. The expansion has stretched space so thin that particles never meet. Nothing happens. Nothing changes. Time ceases to have meaning because there are no events to mark its passage. This is the heat death, the big freeze, the ultimate equilibrium. The 200 sextillion stars were just the kindling. This is the ash. Now, pause, breathe. That feels distant. That feels like a ghost story about a future that doesn't concern you. But here is the twist, the knife in the ribs that brings the horror back to the present. We always ask, where is everyone? We look at the 200 sextillion stars and ask why we are alone. We feel small. We feel late to the party. We assume there were great ancient empires that rose and fell before we crawled out of the ocean. But look at the timeline again. The universe is 13.8 billion years old. The habitable era will last for trillions, the black hole era for Googles. We are not late. We are early. We are incredibly, terrifyingly early. We are the first ones here. The universe has just barely opened its eyes. The stars have just turned on. The heavy elements needed for life, carbon, oxygen, iron, have only recently become abundant enough to build complex biology. We are not the children of the universe. We are the firstborn. And that is the most isolating thought of all. It means there are no elder gods to save us. There are no precursor civilizations to leave us a map. We are the ancients that future civilizations, if they ever exist, will speculate about. But there is a darker implication to being first. It means we are the only ones who will ever see the universe like this. We live in a unique, fleeting moment where the sky is full of light. We can see other galaxies. We can see the cosmic microwave background. We can understand our origins. In the future, because of the expansion of the universe, the other galaxies will disappear over the horizon. They will move faster than light, receding from view forever. A civilization born 100 billion years from now will look up and see nothing, just their own galaxy, a stagnant island in a void. They will have no way of knowing that the universe is expanding. They will have no way of knowing about the Big Bang. Evidence of the cosmos' origin is being erased. We are the only witnesses. We are the archivists of a reality that is deleting itself. So, when you ask, how many stars are there? And the answer comes back 200 sextillion. Do not feel small. Feel burdened. You are the eyes of the universe. You are the mechanism by which the cosmos sees itself before it goes blind. Go outside again. Look at the 3,000 points of light you can see. Know that behind them lie the 200 sextillion you cannot. They are burning. They are raging. They are dying. They are a forest fire that we have mistaken for a lantern. The numbers are not just mathematics. They are a diagnosis. The patient is terminal. The fever is high. The stars are burning through their reserves with reckless abandon. Enjoy the view. It is a limited time offer. The silence you hear when you look up is not peace. It is the held breath of a predator. It is the sound of a clock ticking in an empty room. The stars are not there to guide you. They are not there to comfort you. They are there to burn. And we are here for a brief, flickering moment to watch the fire